In this video, we'll look at graphing 4 different sine and cosine functions. These will have different combinations of transformations, including amplitude and period from the last video, but also horizontal and vertical shifts now. For example number 1, we have y equals sine of x minus pi halves plus 3. The good news about these transformations is they work the same way they always have. So the number inside the function will move the graph left or right, and the number outside the function will move the graph up and down. And when I have to graph something that has multiple transformations like this, I like to answer all these questions first because that helps me get an idea of what the graph is going to look like. In the last video, we learned that the period was 2 pi over b, and in this problem, the b value is just 1. So this would be 2 pi over 1, which is just 2 pi. Knowing the period helps me label the x-axis because I know how far it's going to go. And remember, we like to go 12 grid lines out and label that 2 pi, or whatever the period is. Next, we're asked about the amplitude. Remember, that was just the a value in front of the sine function, which in this case is also just 1. So this graph will reach 1 unit above and below its middle line. Now, in the last video, the midline was always at 0, but in this video, we're shifting things up and down. In this case, we're shifting it up 3 units. So the midline would be the equation y equals 3. So if I numbered the y-axis going up by 1s, that would put 3 up here, and that wouldn't be a good idea because the sine function would be going above and below that value of 3, so it would be off the graph for a bit. So what I'm actually going to do is something kind of weird. I'm going to label this x-axis as actually being 3. And then from there, I'll just go 1 unit per grid line. So really, this would be the x-axis. Now this graph was not only shifted up 3, but also right pi over 2. So remember that the inside of the function works the opposite. Since it's minus, you'd think that would mean go to the left, but it actually means go to the right. So hs is horizontal shift, and I'm going to write right pi over 2. And vs is vertical shift, and I'm going to write up 3. I'll leave the rest of these questions for after we graph it. So knowing that it's moved right pi over 2 and up 3, you have to think of what the sine function originally looks like, which, remember, it starts at the origin, goes up, and then down, down, and then back up again. So knowing that it starts at the origin, I'm going to take that point and I'm going to move it up 3 and right pi over 2. So this is like my new starting point. Once I have my starting point, I like to know when the graph is going to repeat. So knowing that the period is 2 pi means I have to count out 2 pi units in each direction and then plot a repeat point. So according to the way we numbered our graph, we went 12 units out and that was 2 pi. So from this starting point, I'm going to count 12 grid lines to the left. And that puts another point here at negative 3 pi over 2. And the reason I went to the left is because if I counted 12 grid lines to the right, I'd actually fall off the graph. So now we can easily graph one period of this function by starting at this left point and then just oscillating up and down to the right point. I do want to be kind of accurate though, so halfway between these 12 units would be 6 units in, that would be right here. Sine has another equilibrium point, or another middle point. And then right between these 2 points, it has its max point. And since the a value is positive 1, I know the graph is going to start by going up first. So then over here, between these 2 points, it must have its minimum point. So here's one period of the sine wave, and then we can just extend that pattern. So it's every 3 grid lines, I have to plot a new point. So here's the middle point, and then at pi it'll be at its max point, 3 pi over 2 is back at equilibrium, and then 2 pi would be at its minimum point. And then just do the same thing to the left. So 3 grid lines to the left would be the next point, it's at its minimum there. So there's our sine wave. Now that I have this graphed, it's easy to see that the maximum of the sine graph is at 4 and the minimum is at 2. So the range I'm going to write as bracket 2, comma 4. And again, the a value is positive 1, so there wasn't a vertical reflection. So in general, the process I follow is I first figure out the value of the period, which helps me label the x-axis. The amplitude and the midline together help me label the y-axis. After that, I look at the horizontal and vertical shifts, and that tells me where the starting point is going to be. And then we just count out one period to the left or to the right and repeat the pattern. So let's take a look at example number 2, which is y equals the cosine of x plus pi minus 2. Again, this function has a b value of 1, so the period would be 2 pi over 1, which is just 2 pi. And that means I can label the x-axis with that normal 12 grid line spacing, putting 2 pi out there. Next, I see that the a value is positive 1, which means that's the amplitude, and the midline has been moved down 2. So that would be the equation y equals negative 2. And in this case, if I put negative 2 here and knew that the amplitude is 1, that just means it's going to go 1 unit above and below this point. That will still fit on the graph. So I'm going to label it this way, putting 0 in the middle, and then just one grid line per unit. I'm going to draw a dotted line at -2 though, just to help me see where the middle of the graph should be. Next, I see that this graph has been moved left pi and down 2 for the vertical shift. So from 0, I'm going to go left pi units, which puts me right here, and that's where the graph is going to start. But remember that the cosine graph actually starts at its maximum point. So like the parent function for cosine starts here and then dips down from there. So it's kind of confusing, but over here at -pi, it's going to start not on this purple dashed middle line, it's going to start at its maximum point, which since the amplitude is 1, that's 1 unit above the purple line. So the starting point for this cosine graph is actually going to be here at -pi, -1. From there, I'll just measure out 2 pi units to the right now, because if I go to the left, that'll fall off the graph. But if I go 12 units, because remember 2 pi was 12 grid lines, so if I count 12 grid lines to the right, this graph will have a repeat point at its maximum. So counting 2 pi units to the right puts me at +pi, and then I basically just have to make this shape happen between those 2 points. So in the middle of the 2 points, it'll have its minimum point. That's going to be 1 unit below the dashed line, so that'd be here at -3. And then in between the maximum and the minimum, it has to go through its equilibrium point. That's right on the dashed line, and then same thing on the right side. So here's my 5 critical points for graphing cosine, and then after that you just repeat the pattern to the left and the right. Now that I have the thing graphed, it's easy to see that the maximum of the graph is at -1 and the minimum of the graph is at -3. So writing the range, again I'll use interval notation, so bracket, always start with the smaller number, so -3, comma, -1, and then end the bracket. Again, we're using brackets because we do want to include these max and min points. And this equation had an amplitude or an a value of +1, so there was no vertical reflection. Let's follow the same process for example number 3, which is y equals -2 times the sine of x plus 3. So there's nothing inside the parentheses. That means it hasn't been shifted left or right, and there's also no effect on the period. So again, the period is 2 pi over b, in this case that's 1, so it's just 2 pi. So then I label the x-axis the way we have been for all the other examples, and then look at the amplitude, which is, well, the a value is -2. We just say that the amplitude is just +2, because that's just the measurement. It's like a positive distance from the midline to the top of the graph. But knowing that there's a negative in front tells me that it is vertically reflected. And this +3 is outside of the sine function, so that's going to move it up 3, putting the midline at y equals +3. There wasn't any horizontal shift though, there's nothing inside those parentheses, so I'll write none there. And the vertical shift was up 3. So I'm going to do the same weird thing I did in the first example and label this x-axis as actually being 3, because the amplitude is 2, so I need to get 2 units above and below this point. And doing this just helps everything fit nicely on the graph. So truly the x-axis is down here at 0. I'm just relabeling the graph so that the midline is right in the middle of the graph, and that'll just make it really easy on us. Now looking back at the original equation, it's a sine function, which remember the parent function for sine starts at its equilibrium point and then it would normally go up first, but this function has a vertical reflection, so it's actually going to go down first and then come back up. This graph hasn't been shifted left or right anywhere, it just moved up 3, so I have to put its equilibrium point at +3. I don't have to go left or right anywhere, so it's just kind of like at the original origin, but now it's moved up 3. And the period is 2 pi, so if I count those 12 grid lines to the left and to the right, I can put this repeat point out there. So on the parent sine function, right in the middle of its first and last points for the period, it has its equilibrium point again, so I'll do that on the graph. Right between 0 and 2 pi, that would be positive just pi, I would put another equilibrium point, and then same thing to the left, so -pi, there's another equilibrium point. Now remember this graph was vertically reflected, so between this first and second equilibrium point, it's actually going to go down first and then come back up. And the amplitude is 2, so from 3 here, I've got to go down 2 units. So it's got to reach this minimum point of 1 right in the middle of those two. And then it's got to reach this maximum height of 5 right in the middle of pi and 2 pi, and then come back down. Then we'll just do the same thing going to the left. So between -pi and 0, we'll have its maximum point at 5. It'll come back down through -pi, and then between -pi and -2 pi, it reaches its minimum point at 1, and then come back up. And now that it's graphed, I can easily see the range because it goes from +1 to +5. So I'll write that in interval notation. Our last example is another cosine function, and we'll follow the same process again. So we'll first figure out the period, which is 2 pi divided by b, but in this case the b value is actually 2. So 2 pi divided by 2 is just pi. That means that I'm going to label this x-axis a little bit differently. I'll still put 0 in the middle, but I'm going to count out 12 grid lines and label that as pi. So right in the middle at 6 grid lines, that's half the way to pi, so that would be pi over 2. And then half of that at 3 grid lines, that would be pi over 4. So this is 1, 2, and then this would be 3 pi over 4. And then label the negatives as well. Next we look at the amplitude. So the a value in front is -1. So the amplitude is just 1, but it is vertically reflected. And for the middle line, I can see that the graph hasn't been moved up or down at all, so it's just going to be y equals 0. So to label the y-axis, I'm actually going to stretch it out a little bit and put 1 at 2 units above it and -1 2 units below the x-axis. Now this problem is worth putting like a star by for the horizontal shift because it's kind of a special problem because we have a b and a c value. Like we got two things going on inside the parentheses. So anytime you have this, you actually have to factor this b value out of both terms in the parentheses. So what this means is I'm basically trying to pull 2 out of the parentheses, but you have to do that out of both terms. So if I wrote a 2 out front and then started my parentheses, in the first term, if I divided that by 2, I'd be left with x, and if I divided this by 2, I'd be left with pi over 2. And it's still plus in the middle. Now thinking backwards might help make this make a little bit more sense, because if you multiplied 2 back into these parentheses, you'd have 2x, and then 2 times pi over 2 gives you pi, just like we had originally. And the reason we do this basically comes down to the way we graph these functions is we always put the starting point down first, and to do that we have to follow the horizontal shift first. From there we think about stretching it horizontally, but up here order of operations would say that we would like stretch it horizontally first and then shift it left or right. So if we're going to use the idea of transformations to graph these things, we do have to rewrite the function in transformation form. So all of that is to say that this function was actually moved left pi over 2, and there was nothing for a vertical shift. So this means I'm going to put my starting point at negative pi over 2. But remember this is a cosine function, which starts at its maximum point, but remember this was vertically reflected, so it's actually going to start at its minimum point. So thinking through that one more time, cosine normally starts at its maximum point, dips down to its minimum, and then repeats at its maximum point. But this was vertically reflected, so it'll start at its minimum, come up, and then repeat at its minimum again. So my starting point is at negative pi over 2, but it's actually going to start at its minimum, and the amplitude is 1, so I'm going to start 1 unit below the equilibrium line. So here's like our midline, and I'll start 1 unit below that, which is at -1. Alright, now I have to count out pi units to the right or to the left, so I'll go to the right so it'll actually fit on the graph. And pi units, that was, well, like pi was put 12 grid lines out, so from this point I'm going to count 12 grid lines to the right and repeat that point. And now I have my starting and end point, and now I just have to fill in the rest of the graph in the middle. So right between the two minimum points, it reaches its maximum point, and that'll be 1 unit above the equilibrium line. And then right between the min and the max, it has to go through equilibrium, and then same thing on the right. So here's my 1 period of the cosine graph, and then you just continue that pattern on. What's interesting about this graph is after moving it left pi over 2 and then vertically reflecting it, it actually kind of looks like the original cosine graph, because right here in the middle, it actually starts at its maximum point. But that's just a coincidence. We still really think about this as a starting point and then going from there. So the range goes from -1 to +1, and one last time I'll write that in interval notation with brackets.